break. Forgetting to shut it off. She'll probably realize and shut it off, or be worried that when is it going to come back on. Okay, so permutation is really what we've been doing, and the word permutation, if you are talking to a mathematician, you're talking about putting something in an order, that's the word that they would say, how many permutations, or all, I wrote down all the permutations of that, right? That's actually what the word permutation means, is putting them in an order, okay? The permutation formula itself can only be used if there's no repetitions, so 5, 4, 3, 2, 1, right? You take one out every time, and order is important. We're putting something in an order, which is the definition of permutation, and the numbers go in descending order, right? No repetitions. So an example of that, as opposed to the ones we just did where they didn't necessarily go in descending order, would be arrangements. So say we want to arrange 5 books on a shelf, and we have 12 books to choose from. So we've got 12 books, and we're just going to choose 5 of them to put on the shelf or on a display, maybe at the library, something like that. We're making an arrangement, but there's only 5. 1, 2, 3, 4, 5. How many choices for the first spot? 12. Second spot? 11, 10, 9, and then 8. And then you just multiply those, okay? Or you could say this is 12P5. Out of the 12 books, pick 5 of them to arrange. And that's how the formula works. So the actual formula itself, like why is there a divide there? Because if you write 12 factorial and then we subtract them, 12 minus 5 is what? Right, it's getting rid of the 7, 6, 5, 4, 3, 2, 1. That's what it's doing. So it's saying 12 factorial and cancel, that goes all the way down 3, 2, 1, and then cancel off everything. Does that make sense? Like this goes 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, no room, 2, 1. And this is 7, 6, 5, 4, 3, 2, 1. It leaves us with what we wanted. So that's why there's a division in there. If you were arranging all 12, the division would be divided by 0 factorial, which is 1, so it wouldn't be taking anything off. So that's what the permutation is. So really you don't need it, but if you see that the numbers go down and there's a lot to type into the calculator, then use the formula instead, right? But you probably wouldn't jump right to the formula from the question. You would instead put the lines and say, this is what we're doing. So I sort of always just put the lines if I'm doing an arrangement and just ask myself, how many choices, how many choices, how many choices? If it's going to be quicker for me to plug into the calculator, I'll then write it this way and do it. But if it's just short, I might just type in the 5 numbers. Okay. So on the calculator, you would do like 12, second function, and the P is above the 6 on mine, so I hit that. Can you see the screen? I don't know. What was it? 5? So 95,040. 95040. That's a lot of ways that you could arrange 5 books. So combinations is where order is not important, so not an arrangement. So it's hard to think of what a question would be that's not an arrangement when this is kind of what we're talking about, but this would be an example. So a similar question, suppose we have 10 books.
So repetition is allowed?
Repetition hasn't, it wouldn't be, it has no relevance, yeah. But it, you wouldn't repeat, because you're still picking items, usually from a lot of items, like a bunch of balls, say, and you're picking some. Remember when I had the container last class and I had some pencils in it and some chalk? That would be a combination question, because you can't sort of tell them apart, and if I had picked like 3 of them out, did it really matter if I picked 2 pencils and a chalk, or a chalk and a pencil and then a chalk? If I ended up with the same thing in my hand, I wasn't lining them up. Permutation is when we line them up. If you were just picking them to hold them, that's a combination, because it doesn't matter what order you pick them in. So that's, suppose we have 10 books. So I can make 2 types of questions out of this. I can make a a combination, and I can make a permutation. Okay, so arrange 5 on a shelf. Is a permutation. So that would be 10P5, or you could put the lines and do it that way. Okay, so what makes it not a permutation is, say we are choosing 5 to take to school. So what are you doing with them as you're taking them to school? So if you picked the first 5, could you have picked the first 5 in a different order and it's still the same 5 books? Do you still end up with the same thing? Yes, because you're not arranging them. It's not saying how many ways can you arrange them on a shelf or like a display. It's like putting them in a bag or taking them with you. It doesn't matter the order. So that's what the difference is. So this would be 10C5. So which one of these is a bigger number? Permutation, because if you had 5 items, you actually count all the arrangements of those 5 items, which is 120. If you wrote all 5 items down, after you picked which 5 out of the 10 you're using, you could arrange those 120 different ways. Combination, that's 1. Just 1. You pick your 5 books, it doesn't matter if you shuffle them, they're still the same 5 books. So this is different by 5 factorial, which is 120. This is 120 times less. It's like the indistinguishable permutations by however many you pick. We're picking 5 items and we want to divide it out by 5 factorial. So this is like 10 factorial divided by 10 minus 5, which is 10 factorial divided by 5. Okay. This one is 10 factorial divided by 5 factorial and 10 minus 5 factorial. So this is the same as that part with this added on to it. We're dividing by the ones you're not arranging those 5 once you pick them. You're just saying it's one way, so we divide it. So this is smaller by 5 factorial. $30240. $252. 252 times 120 will give you this, or times 5 factorial. Okay, so suppose there are 10 people. How many ways can 3 be selected to win $10 each? Okay, so here's 10 people in a draw, and there's 3 different questions we can consider. So how many ways can 3 people be selected to win $10? How many ways can 3 people be selected? So the first person is 20, the second is 10, and the third is 5, so they get different prizes. And how many ways can 3 be chosen if the names are replaced after each name is chosen? So the same person could win $30, right? They could. So what do you think? So this is a question that has one of each. One that is multiplication principle, one that is a permutation, the numbers go down, and one is a combination. The order doesn't matter. So what do you think? So the first one, 3 people are getting $10 each. If I pick 3 of your names, can I shuffle them up and you still get the same thing? So that's a combination. The order didn't matter. If I pick Shannon, Heather, Colin, Colin, Shannon, Heather, or any of those, it doesn't matter. They got the same thing. Okay? So this is a combination because they're getting the same prize. So same prize is a combination. If you're picking people and they're getting the same thing, then it's always a combination. You can shuffle them around, it doesn't matter. And the other example you'll see in the practice questions is like people getting a job. If I'm picking 3 people to get hired to be tutors in the Math Learning Center, it doesn't matter what order I pick them. They get the same job, right? But if you were getting different jobs, then it does matter. President, vice president, secretary, that would matter, okay? So this is different prizes is a permutation, which again, you don't need to use the permutation notation for it, you can just multiply. And how come this is a multiplication principle? The names are replaced, so it doesn't go down, like there's 10 people in the draw, and then when you go to draw the next person, there's still 10 people in the draw. So the names don't go down, so it would be just a multiplication principle. So that's the replacement is multiplication. All right, so what's the answers to all of these? 10 people in the draw, and we want to pick 3. There's no way to write lines for that. You just use a combination. This one, 3 people, they're all getting different prizes. You're picking 10, then 9, then 8. So this is 10P3 if you want. And then the last one is what? 10 names, 10 names, 10 names, which is 10 cubed if you want a shorter way to calculate it. This is 720, and this is 120. Okay, so that's sort of the differences, and what we're going to do in the last 5 minutes is just combinations, because there's like a classic combination type question that we want to cover. So combinations, so permutations are used when you're talking about arrangements, arranging something on a shelf, usually. Could be people putting them in seats for a photo because that's lining them up. It could be words because that's an arrangement. License plates, phone numbers, anything that's like a display that you can't change it around or else it's different. combination, the classic problem is this. So, and then we can make tons of different questions off of this. It is, they say balls in an urn. That's the classic question. So basically, you've got a container, and you've got something in the container. So I've put jelly beans in a jar before, cookies in a jar, you know, pencils and chalk in a box, right? Anything where there's stuff that you can't tell them apart, usually. So balls in an urn would be like, there are 10 red and 7 green balls in an urn. How many ways can 4 balls be selected? And it's like they're all the same. It doesn't say selected to line them up, right? It's just selected. So you pick 4 and then you look at what's in your hand. You know, the cookies one is good, like how many ways can you get 3 chocolate chip and 2 ginger snaps, right? Like that kind of thing. So we're going to add to this, but this is just like the total. This is like the total. How many ways can 4? It doesn't say anything about the colors that you want to get. How many total is there? 17? And we're choosing 4. So that's just the total. It doesn't say anything about what color you want. But then we can change the question. So we can say, how many ways can 4 balls be selected if 2 are red and 2 are green? So you've got a multiplication in here because you're doing 2 things, but what you're doing, the order doesn't matter. You just want 2 altogether. So we actually say, like, there's 17 altogether, 10 are red, and 7 are green. And we want to select 4. That's what the experiment is, selecting 4, okay? So we've got 17 total, and this is how they're broken down. You could have as many groups as you want. I could list 10 colors, and there's all in there. But it depends what they're asking for. So here we're saying we want 2 red and 2 green. And is multiply. So how many red are there altogether in there? 10. And we want 2 of them. So this would be 10C2. Out of the 10 red, we want 2 of those. Doesn't matter which 2. And out of the 7 green, we want 2. And you would multiply these, and that would give you the answer. Add or is add. Exactly. So we would say for the same color, so we want 4 red or 4 green. Does that make sense? And or is add. So that's sort of the 2 differences. What you have to do with these sort of combination questions is write a sentence like that, exactly what they're looking for, and then you put either plus or multiply, and you write your combination. So, or out of the 10 red, we want 4, or out of the 7 green, we want 4. Not and, because you're not going to pick 8. We want one or the other. Does that make sense? So 245. Okay, so what I'm going to do, I don't want you to write them down, but I've got another example worked out here, and I'm just going to talk you through it, and I'll post the notes, okay? Just so that it'll be quick and you have a second example, okay? So we're going to talk through it. It's all written out from when I did it in class last time. It's really the last example in this whole section anyway, so we almost made it to the end. But instead of rewriting it and you writing it, we're just going to listen. So this is the notes that I'll post. So it says combination problems. Basically, they're set up this way: total, and then there's different groups. So I had red and blue, but you could have 3 groups. You could have more than 3. But basically, that's it. And you're selecting a certain amount more than one. If you're just selecting one, we did that last class. Like, you know, if there's 5 red and 2 blue, and you're selecting one, you can either get 1 red or 1 blue. That's it. There's nothing to count. Right. Classic combination is balls in an urn, so I said that already. So here's like the total number of balls: color 1, color 2, color 3, color 4, however many colors you want to put in there, and then we're selecting a certain number. Okay. So I've got the second example here. So this one is 10 red, 5 black, and 6 green. So 3 instead. 4 balls are selected. How many ways can we select 4 balls of any color? So that's the total. It doesn't matter what the colors are. So it's just the total is 21 altogether, and we select 4. So 21C4. Okay, so when they don't mention a color, it's just the total. All the same color, so we just did that, right? This time it's 3 choices. So out of the 10 red, pick 4, or out of the 5 black, or out of the 6 green, pick 4. So or would be add. Two red and 2 black. So they don't mention the, what's the third color? Green. They don't mention the green, so you don't count it. So they want 2 red and 2 black, so out of the 10 red, pick 2, and because we want 4 altogether, out of the, right, this adds up to 4, because that's how many we were selecting altogether. That's what I said here. They add up to 4, because we're picking 4. 2 red. So this is where it's different. We're selecting 4 in the original question, and this just says 2 red. So what are the other 2? Anything. And as I said, so 2 red and, no, this just is 2 red. So 2 red, right, just 2 red, and 2 others that aren't red. Right, so how many red were there? 10. So out of the 10 red, we want 2. And this is the 11 others. So there were, the others are, what, 5 black and 6 green. There's 11 others. So out of the 11 others, pick 2. So the red's not included here. So we've got 2 red and then 2 of something else. They could be 2 black, 2 green, or 1 of each. At least 2 red. So this is where you have to say, what does that mean? 2 red or 3 red or 4 red. We're picking 4 altogether. So an or is add. So if we want 2 red, right, so what you kind of say here is like, this is 2 red or 3 red or 4 red. But we need them to add up to 4 each time. So this would be 2 red and 2 others. That would be the 4. Or 3 red, and then you'd need 1 other. Or 4 red. That's it. That's all 4, so you don't need any others. So what are the red and then the others? The red and then the others, we want just 1. And 4 red, we don't need more. So in between plus signs, they always have to add up to 4. Right, because all your options always have 4 in it. All right, and that would be that. Here I was just talking about this is the opposite. Like I said, what's the opposite of this? I could ask for, the opposite would be 1 red or no red. Right, if this is 2 red or 3 red or 4 red, then the opposite would be 1 or none. And so if we figured out the opposite and this, they would add up to the total. Right, the number in E, whatever E is, plus the number not in E, add up to the number in the sample space, like the total, with not regard to color. So that's what this was. Just showing that that makes sense if you do the opposite. So then this is the last example. Manufacturer of pens selects 7 pens from a box to check for defects. Suppose that a box contains 50 pens, of which 15 are defective. So how is this a ball and an urn question? We've got a box with pens in it, and there are 2 categories. 15 are defective and 35 are not. So instead of colors, they're defective and not defective. So here I said, like, these are good. So 35 are good and 15 are defective. So instead of colors, that's what's in there. And then you can ask any of the same question. How many ways to pick? So how many samples have only 1 defective? So that would be 1 defective and 6 good. Because your sample is selecting 7. Right? So if we want just 1, that's 1 defective and 6 good. So out of the 15 defective, pick 1. There's 35 good, pick 6. And that's a crazy amount. And then I could ask anything about it. How many samples have 3 defective? So that would be 3 defective and 4 good, because they have to add up to 7. So out of the 15 defective, 3, and out of the 35 good, 4. At least 1 defective, and this is whiting all of them out, but because it's 7 instead of 4, at least 1 defective means what? 1 defective, or 2, or 3, or 4, or 5, or 6, or 7. That's a lot to add up. So that's why doing the opposite sometimes is better. So this is 7 possibilities. 1 defective, 6 good. Or 2 defective, 5 good. Or the opposite is what? No defectives. So if you know the opposite, you can subtract it from the total. So look at that closer, but 15C0 just works out to 1. You don't need to put that because you're not really picking anything. When you pick 0 of something, it's no choice. So it's like 7 good is the opposite. So that works out to this, and then you could subtract it from the total. You don't have to. You could add up all of these, but that's a lot of typing. That's basically it. So the questions are always, the combination questions like these are usually pretty obvious. It's a container with groups of something in it. Yeah. So I'll put those papers there and then you can just practice some and just text me if you have any questions when you're studying on the weekend or anything. Yeah. And then we're done with this section. We start something totally new. Finance is next, which is interesting. This is the hardest stuff, this section. Just make sure you practice. Actually, there's another example here I'll just add to the back, too, that we didn't look at. 10 women and 12 men. So they're the groups of people. So there's 22 people altogether. How many ways can 3 people get a job? So it's just another example. just add it to the back. So I'll post these all tomorrow. Oh, shoot.